Assalamu alaikum dear students. Today we are going to start a new chapter, that is chapter number 6, and this is about applications of definite titles. That is, whatever we have learned in chapter number 5, we are going to apply in chapter number 6. So let me tell you one thing. This is one of my favorite parts of the calculus, and I always love teaching this section. Initially, it is little intimidating as we are first time getting familiar to three dimension and revolution of the region, revolution of the curve, surface of revolution, and solids of revolution. All these concepts are new for you. But trust me, it is very easy and simple if you think about it right way. So if you keep yourself intimidated by all this, then this section will be the least favorite one for you. But don't let this happen. Try and understand the idea, and I assure you that it would be fun. So let's start the first section of the chapter, that is volumes using cross sections. That is, we are going to learn how to find the volumes using cross sections. So first of all, what is volume? Why do we need to evaluate the volumes, and how can we evaluate? So there is a method of slicing for finding volumes. Then there is solid rock revolution. Then there are a couple of methods uh, used to find the volume of solid rock revolution. Okay, first of all, I'm sure you are familiar with this figure. This is a cylinder with circular base of radius r, and its height is h. So it's easy to guess what is the volume of this cylinder. This is pi r square times h. That is base area times height. So there is another figure which is a cone, and its base is also circular, its height is h. So you can guess what is the volume, that is pi r square h divided by 3. So next we have a rectangular box, or a rectangular prism you may say, with a rectangular base of length L and the width B, that is breadth B, and height of this rectangular box is 8. So its volume is LBH. This is also base area multiplied by height. So our next target is to find the volume of a solid, which is apparently not similar to all these shapes. So what to do for this? That is, if we have to find the volume of such objects like a cucumber, like an apple, like a bread. So what do we do? So the answer is slice the solid into pieces, that is small cylinders, and find the volumes of these small pieces and then sum them up to find the volume of the object. So we have to slice all this into the smaller pieces. Now you can see that we can find volume of one slice in each case. In this case, this is a cylinder with the circular base, and this thickness of this piece is actually the height of the cylinder. Similarly, in this case, this is also a circular shaped, circular base cylinder, and in this case, base is not a circle, but we can find the area, and if we can find the area of the base, then we can find the volume of one piece, and by adding all these volumes we can find the volume of the whole object. Now this idea actually leads us to a method which is called method of slicing. So let's see. Before that, we have to define the cross section, because this article is about volumes by cross section. So first of all, let's define the formal uh, definition of cross section. So you can see here is a plane which crosses over the sphere from -4 to 4, and you can see the intersection of the plane and the sphere changes at every point. Although it's a circle, but radius of the circle is changing from every point from -4 to 4. But we can find area of the circle. So by adding all these areas, we can find volume of the square. So what is the cross section? Cross section of a solid S is the planar region. That is this circular region, which is the intersection. Planar region formed by intersecting S with the plane. So this is the solid S, and this is the plane. So if when we intersect a solid with the plane or cut the solid with the plane, then the intersection is called the cross section. So this cross section, area of cross section, help us actually finding the volume of the solid. So here we go. There is the solid S, and this is the cross section. That is the intersection of this plane and the solid. If area of this cross section is AX, and if this area is continuous function of x, then the volume of the solid S is the definite integral of AX. So summation always actually gives rise to the integration. So this method of computing volume is known as method of slicing. So that is why we were stressing about slicing and sliced regions and slices and all that. So let's have the kth slice of the volume, solid, kth slice of the solid in the interval xk minus 1 xk. So this is the slice, kth slice, and this is the area of the base of this cylindrical region, which is, let it be axk, and this is the height. So this height is in fact length of this interval. So length of the interval is xk minus 1, that is delta xk. So what is the volume of this little piece of the solid? This is base area multiplied by height. So base area in this case is axk and height is delta xk. So by adding all such areas, we have the Riemann sum, which looks like this. Now letting this length of the interval to 0, we have the volume of the solid is equal to integral from a to b ax dx. So here is the formal definition of the volume of the solid of integrable cross sectional area. So this is very important. This area must be integrable from x is equal to a to x is equal to b is the integral of a from a to b ax dx. Now what are the steps we are going to follow to solve the problems related to volumes? First of all, we have to sketch the solid, or at least we have to sketch the typical cross section. Find a formula for AX, that is the area of cross section, typical cross section, and then find the limits of integration, and finally integrate this AX using fundamental theorem of calculus, which we learned in previous section, that is previous chapter. So here is an example. A curved wedge is cut from a circular cylinder of radius 3. Okay, so we have a circular cylinder of radius 3 by two planes. So this wedge is cut by two planes. So one plane is perpendicular to the axis of cylinder, that is parallel to the base, perpendicular to the axis of cylinder, that is this is going to be the base of the wedge, and the other, the second plane, crosses first plane at 45-degree angle at the center of the cylinder. So this is the center of the cylinder. So next plane will be passing through the center with 45-degree angle. So this is the closer view of the wedge. This angle is 45 degrees. This is the base of the wedge, and since radius is 3, so this length is 3, this length is also 3. uh, from this point to this point, this is also 3 because this is the semicircle, and this angle is 45 degrees as given in the question. This angle is 45 degrees. Now let x be any point in the interval 0, 3, that is in from at x-axis. X be any point, then the cross section of the wedge. What is the cross section of the wedge? Now question here is finding cross section of the wedge perpendicular to x-axis. So when we cut this wedge by the plane perpendicular to x-axis, this is the plane perpendicular to x-axis, then the resulting cross sections are the rectangles like this. This is the rectangle. This is the rectangle. Now in order to find this area of this cross section, we have to find the length and width of the cross section. So length of the cross section is x, width of the cross section is x. So we have to find the other dimension of this rectangle. So for this, let's draw a triangle here. Now this side of this triangle is known, which is x, and this is known because this is radius. So this is 3. And since this plane is perpendicular to x-axis, so this angle is 90 degrees. Now by using Pythagoras theorem, and let this side be y. So if we have the value of y, then 2y will be the length of this rectangle. Okay, so let's try and find out the value of y. So by using Pythagoras theorem, this is the hypotenuse. So we have 9 is equal to x square plus y square. So y square is equal to 9 minus x square, or y is equal to, in fact, square root of 9 minus x square. Now positive value of the y lies in the first quadrant, and the negative value of the y lies in the fourth quadrant. So total length of this is 2 times the absolute value of this, which is 2 times square root of 9 minus x square, because length can never be negative. So we have to take the absolute value of this. So now we have length and width both. So area of cross section is going to be length multiplied by the width, because this cross section is a rectangle. So x multiplied by 2 times square root of 9 minus x square. Now the next target is to find the limit, and then we'll integrate the volume integral. So volume integral is a to b ax dx, and which is equal to, so x varies from 0 to 3. So we are going to integrate with respect to x. So we have to find the limit for x. So 0 to 3, area is 2x square root of 9 minus x square dx. Now you have to integrate this definite integral in order to find the volume of this wedge, and you will be doing it yourself. And let me write the answer, which is equal to 18. So verify it yourself. So this is how we can apply the formula just learned for to find the volume. Okay, next, solid of revolution. Actually, name tells us all that we are going to revolve something in order to get this solid of revolution. So first, let's see what is solid of revolution. A solid of revolution is obtained by rotating a plane region like this. This is the plane region. plane region about n axis, any axis. In this case, we rotated this plane region about y axis, and in this case, plane region is rotated about x axis. So, solid generated by rotating a planar region about an axis is called solid of revolution. So, we have lots of examples of solids of revolution around us. So, let me show you a few. Okay, next target. How to find the volume of solids of revolution. So, first way to calculate its volume is by cross sections perpendicular to the rotation axis. So, if we take the cross sections, if we rotate this region around x-axis, we have this solid, and by taking cross sections, we have circles, and then we use the area volume formula we have just learned, A to B, area of the cross section dx. So this is the volume, and this so first uh, we are going to follow this, but first case for this method is that there is no gap between the region and the axis. That is, region to be rotated is attached with the axis of rotation. So this is the case, and this is the case when there is no gap between the regions and the axis. And the method used to find the volumes is called disk method. So here is the formula for disk method. If we are rotating the horizontal axis, rotating about the horizontal axis, and not necessarily x-axis, any line parallel to x-axis would do. So if we have the region, so let's see how can we have this formula. This is the region, and we are rotating it about x-axis. Then what actually we are rotating, if we have a cross section, then we are in fact rotating a line. This is the curve y is equal to fx. So we are rotating a line. When we are rotating a line, then we are obtaining a circle with radius equal to the length of this line. So what is the length of this line? Length of this line is the value of the function at this point. Okay, so if this is x, then fx is the length of this line. So the cross section is circle. So what is the area of the circle? This is the radius of the circle. So area of the circle is pi times radius of the circle. Radius of the circle squared. So this is the area of the circle. So the target here is to find the radius as a function of x. So volume is equal to integral from a to b pi rx square. So while rotating, we are going to have circles when there is no gap. Cross sections are circles when there is no gap between the axis of rotation and the region to be rotated. Like this. There is no gap between the axis and the region. Or like this. So here is an example. Calculate the volume of the solid generated by rotating the region between y is equal to square root of x and y is equal to 0. From 1 to 4. That is A and B here are 1 and 4 respectively. So this is the region, planar region, and this is rotated about x-axis. So first of all, what is Rx? We have to find the value of Rx. As I told you before, that Rx is in fact, in this case, is Fx. Okay, so Fx is square root of x. So we are going to plug in the values. A here is 1, as I told you before. A is 1, B is 4. So Rx square is square root x square, and pi is from formula. And by integrating and doing some manipulations, we have the value of the volume equal to 15 pi divided by 2. Okay, next question. The semicircle of radius A is revolved around the x-axis to give us a sphere. Okay, we have a semicircle of radius A. So this is A, this is minus A, this is the origin. So we are going to revolve this around x-axis in order to have this sphere. So we have to find the volume of the sphere. Again, cross section of this sphere is circular disc. So we have to find the area of the base of this circular disc. So what is the area? So if we have this semicircle, so equation of this semicircle is x square plus y square is equal to a square. Since radius is a and center is origin, so x square plus y square is equal to a square. So from here, y square is equal to a square minus x square. So r square here is a square minus x square. So area is going to be pi times area of cross section is pi times fx. So fx square, pi times fx square. So fx square here is y square. So pi times a square minus x square. Now in order to find the volume, we have to integrate it. Now what is the limit for x? A varies from minus a to a. So a runs over the interval minus a. So pi minus a to a r square, that is a square minus x square, and dx. So this is equal to pi we have to integrate this pi a square x minus x cube over 3 minus a to a, and this is equal to pi a cube minus a cube over 3 minus negative a cube positive a cube over 3. So this is equal to a cube plus a cube, it's 2a cube. Negative a cube by 3, negative a cube by 3 is negative 2a cube by 3. And this is going to be 4a cube pi over 3. So this is the volume of the sphere. Okay, next. Disk method with vertical axis rotation. Now, in previous slides we learned if we rotate a region around x-axis. What if we rotate a region around y-axis? That is, if we have a curve like this and we are going to rotate it about y-axis. This is x-axis, this is y-axis. So what type of solid we are going to have? We are going to have the solid like this. So in this case, what is the radius? Now, radius is going to be this length. Okay. So what is this length? This is the value of x at some y from a to b. Okay. This is y. This is the value of x. That is, we have to convert our representation of function as x as a function of y. So we have to find this. This is the radius in this case. So our area is going to be the function of y now. So volume will be integral from a to b pi ry square dy. So target is to find radius so that we can find the area of cross section of this solid of revolution. So in case of rotation about vertical axis, the volume formula will be integral from a to b pi ry square, that is our radius is the function of y. So here is an example. This is the curve y is equal to x cube. We are rotating it around y axis. So conversion of x in terms of y gives us x is equal to cube root of y, and this is bounded. Y is bounded above by 8 and bounded below by 0. So a and b here are 0 and 8 respectively. So let's try to find. So here is the manipulations. You can evaluate this integral, and the volume of this solid of revolution is equal to 96 pi by 5. You can verify this by doing these easy integration steps. Okay, solid of revolution. If there is a gap between the region, now there is a twist. Now axis of revolution is x-axis, and the area we are going to rotate is given by this planar region. And there is a gap between x-axis and the region to be rotated. So the resulting volume will have a hole inside. Okay, so this is not a solid. So cross sections are not going to be circles in this case. They are going to be washers like this. That is why this is called washer method. So in this case, what we are going to do, this height is Rx minus Rx. Now actually this is rotating around x-axis. This length is rotating. So the area of one washer is in fact area of outer circle, that is with radius Rx, minus area of the inner circle. So we have area of the area between the circles. So area of outer circle is pi Rx square, and area of inner circle is pi Rx square. Okay, and when we integrate it from a to b, we'll have the volume of the solid generated, and this method is called washer method. So first of all, again we'll see what is the formula when we rotate the region about horizontal axis, and what is the formula when we rotate the region about uh, vertical axis. So first let's see washer method with horizontal axis rotation. That is, we are going to rotate this region about x-axis or any horizontal axis. Then volume is given by this formula. And I told you before how can we find this formula. This is in fact the area of outer circle minus area of inner circle. So outer circle radius is uppercase Rx, and inner circle radius is lowercase Rx. So volume is given by this formula, and let's try to find the volume in this example. So what we have to do, uh, uh, the region between the y is equal to x square, y is equal to x, we have to rotate it about y is equal to 2, that is a horizontal axis. Okay, so this horizontal axis is not x-axis, this is y is equal to 2. So we are going to rotate this around the line y is equal to 2. So when while rotating around y is equal to 2, what is the outer curve and what is the inner curve? This is the outer curve and this is the inner curve. Okay, so the distance from this line to this line will give us the outer circle's radius, and similarly distance from this to this is will give us the inner circle radius. So Rx is the outer circle minus Rx, lowercase Rx is the inner circle. So by plugging in the values, this curve is the outer circle, and equation of this curve is y is equal to x square. Okay, y is equal to x square. Now, since we are going to rotate about y is equal to 2, so what is the value of, let me draw the line so that you can be able to, I'm sorry, I'm not able to draw the straight line. Okay, let's assume this is a straight line. So we have to find this is in fact y is equal to x square. Okay, and this whole length is y is equal to x square, y is equal to 2 from this point to this point, and this length is y is equal to x square. So x square minus 2. So we are actually going to revolve x square minus 2. That is, we are going to revolve this. The length from this point, that is from this curve to this line, and this is in fact x square minus 2. So since uh, we are going to take square, so this is x square minus 2 square, and the inner, in case of inner radius, we have this line y is equal to x, and what is this distance from this line to this line? This is in fact x minus 2. So x minus, we are revolving x minus 2 around this line, so x minus 2 square. So this is the rx square, and this is the rx square. Okay. And this is equal to, now rest is matter of calculation, and you can do it very well. So volume is 8 pi over 15. Okay, now Washer method with vertical axis of rotation. In this case, similar situation here when we were discussing the method of cross sections or method of slicing. In case of the rotation about y-axis, our radius is the function of y. So we have to find the greater radius, and we have to find the low radius, that is the outer radius and the inner radius, and we will subtract the areas of outer circle and the inner circle to have the area of one cross section. And by taking the integral of area of one cross section, we have the volume. So when we are rotating about vertical axis, the function is going to be the function of y, and when we are rotating about horizontal axis, function is going to be the function of x. So next example. Same region, rotate this region around x is equal to 2. In previous slide, we solved this for y is equal to 2. Now we are going to rotate for same region about x is equal to 2. So in this case, we need the formula that is the radius in terms of y. So y is equal to x square gives us x is equal to square root of y. So this is the one radius. Y is equal to x means x is equal to y. So this is the second radius. So again, we are going to revolve this curve for this line for this curve, and this line for the line y is equal to x. That is this. So how to find this line? This is y minus 2, and in this case, sorry, outer is y minus 2, this, and inner is square root of y minus 2, which is this line. This is square root of y minus 2, and this distance is y minus 2. Okay, so by plugging in the values, we have this integral, and rest is just a matter to solve the integral, and after a few manipulations we have the volume is equal to pi r2. Alright, next example. Fx is equal to 2 minus x square, and we are going to rotate it about y is equal to 1. And the question here is how to solve this using any of the methods we learned in this video. Okay, let's think what method we can use to find this volume generated by rotating this planar region around this line y is equal to 1. And this planar region is actually bounded above by this curve. This is 2 minus x square, that is y is equal to 2 minus x square, and this bounded below by this line y is equal to 1. So you can take few seconds to think, and then we'll reveal the solution. So this is actually an exercise what you learned and what you understood. So let's see. Alright, so volume, actually we are going to rotate this height, okay, this height. So this height is coming from this y minus 1, okay. So 2 minus x square minus 1 whole square, this is the radius. Alright, so you can say this, we have used this, we have used disk method to find the volume. So we have to find the right r here. So r here is 2 minus x squared minus 1. Or you can say this is Washer method by saying that they are 2 r's. So, but in this case we have used the disk method, and r here is this distance, y is equal to 2 minus x squared minus y is equal to 1. That is, we are rotating this line, in fact, particular line. Okay, so this is y is equal to 2 minus x squared minus y is equal to 1. So this is our r, so pi r square, and what is the limit? Limit, this is the function of x from this point to this point. This is the point x is equal to minus 1, and this is the point x is equal to 1, so minus 1 to 1, and rest is just a matter of calculation. So answer is 16 pi by 50. So that's all for today, and I'll urge you to practice more and more. If you do try a few exercise questions. Take care. Bye bye.